Okay, 5-4, proving triangle congruency with angle, side angle, and angle, angle, side. Angle, side, angle, okay? So the other day, we talked about two. We talked about one that's a special type of triangle, and we talked about one, we actually talked about three. And we talked about two others with other triangles. What were the three theorems that we can use, or postulates? Side, angle, side, which means what? It's a side, the angle has to be between the two sides that are congruent, okay? So it's special because it's like a sandwich. Okay, side, angle, side. Then you had what else? What were the other two? Side, side, side. All three sides are congruent, okay? Pretty simple. What's the other one? Hypotenuse, leg. So it's only on a right triangle. The hypotenuse and one of the legs have to be congruent. Okay. Angle, side, angle now is a sandwich between the angles. Okay, if angle A and F are congruent, and side AB and FE are congruent, and angle B and angle E are congruent, then the triangles are congruent. So angle, side, angle. This one I think is easier to see because you can literally tell if the side is in between the two angles. You can see the mark, you just read it in order, okay? So that's pretty simple to understand. The other one is angle, angle, side. Okay, angle, angle, side. On angle, angle, side, okay, it would be angle A and F, angle B and E, side BC, side ED. So you're reading it in that order too. You're going angle, next is another angle, then the side comes, okay? So it's not in between, and it's not, it could be side AC as well, because I would go angle, angle, side. So it's the side that's not in between the two angles. Does that make sense? So angle, side, angle has the side sandwiched between the two. Angle, angle, side is any of the two sides that aren't between the two angles. Okay? There is, let me just throw this out there to help you out. There is no angle, side, side. There is no ASS ever. Okay? If you write that on your paper, or if you choose that as an option, it's completely wrong. There is no angle, side, side. That's the only one that never exists. I know that's funny, boys. But for real, there isn't. We don't like cursing. We don't like it in math either. That's how you can remember that. Okay? There is no angle, side, side. Bryson's like, what do you mean? I like cursing. Okay? So there is no angle, side, side. There's angle, side, angle, 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 side, 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 angle, side, hypotenuse, leg. Just throw that one randomly in there. Okay? So that's what you've got going on. Why is it not working? There we go. Okay. Which triangles are congruent? Look at these. Which triangles are congruent? I know the little angle things are messed up weird, but that's okay. So look, here I have, okay, so this is showing that this angle here has two marks, this one has one, this side. This one's this side, this angle, this angle. This one's this angle, this side, this angle. So which two are congruent? What two triangles are congruent? And why? What? Repeat, I just didn't hear you.
A, B, C, and D, E, F.
Okay, triangle, you want to say triangle ABC is congruent to triangle, not DEF, you would have to name it EFD, okay? Because remember, you have to go in order. And why? No.
Angle, side, angle.
Angle, side, angle. Angle, side, angle. Angle, side, angle. Okay? So yes, triangle ABC is congruent to triangle EFD. Remember, when you're naming them, you have to go in order. Order matters. Okay? Okay, here you have two triangles. Okay, and it says translation is isometry. Okay, we talked about isometry before. What does isometry mean?
Does it have something to do with isosceles?
No. What happens to an object when you translate it? it's like the same, it stays the same, it's just shifted, yes? So an isometry is something that has two, they're still congruent to each other, okay? So if you see a translation happening to something, you can prove those triangles are congruent because you know that everything stayed the same. The sides are the same, the angles are the same. You can use side, 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 you can use angle, side, angle, you can use angle, angle, side. You can use, if it's a right triangle, hypotenuse, leg, okay? You can use side, angle, side. So when you see a transformation with a translation or anything like that take place, or even a rotation, if it has isometry to it, then that means that they are still the same, congruency-wise. And you can make an easy proof that way. Does that make sense? Okay? Just wanted to throw that out there. Here we go. Okay. This is just a proof that shows you what we're talking, oh, that's not what we're talking about there, okay? So here's that same picture, okay? They took this original image, mapped it over there, so they slide it across and up, okay? And they say, prove that triangle ABC is congruent to mapped triangle ABC. Well, they said, here's the first thing. Mapped A and mapped B, okay? They show the coordinates of those. And then they said, if you use the distance formula, right, I can prove that the distances are the same on all three sides, okay? So they use the distance formula 1, 2, 3 times and simplified. And then they're gonna use what? If they use distance formula, what are they gonna use to prove the triangles are congruent? Are they gonna use side, angle, side? Are they gonna use angle, angle, side? Are they gonna use angle, side, angle? Are they gonna use side, side, side? If you're using distance formula, think about that. What are you finding? Yeah, you're gonna use side, 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 because I'm finding the lengths of all the sides, okay? So then, you would get something that would look like this, okay? Where it says BC equals mapped BC, AC equals mapped AC, I can use side, 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 okay? So when you are trying to prove a translation, what I would go with is probably using the distance formula and finding the lengths of things. Okay. It says prove triangle SAN is congruent to triangle AST. Okay? Triangle SAN and AST. Okay. How can I prove that these triangles are congruent? So let's talk about that. Okay? First I want triangle SAN, which is right here. Okay, and then I want to compare it to triangle AST. Okay, what do you know from that picture right away? What are some things we can list for our reasons and stuff? What? Okay, ST and A are parallel, perfect. So I'm gonna go statement, I'm gonna go reason, and I'm gonna say segment ST is parallel to segment, if I'm going S goes with A, is parallel to segment AN. Okay, given. What else do we have that's given? Okay, angle N is congruent to angle T, yes? Okay, and that is also a given. Okay, do we have any other given information? I think we do.
Oh, I think,
Well, kind of, but kind of not. We have to kind of prove it. It is given with what we look at, but it's not, the reason isn't given. What?
is it like ATS is like equivalent to, SMA?
ATS. Well, yeah, that's what they're saying with angle N is congruent to angle T. They just made it simpler. But yes, you can state it that way too, Grayson. What? Beautiful, I love it. Segment SA is congruent to segment AS. Why? Not transversal. Reflexive. It's the same thing, it reflects itself, okay, reflexive. I don't know what I'm doing. I can't think.
Yes. IBE, BE. There you go.
S.
Sorry, thank you. I'm Reflexive, okay. So I know that. Okay, so now I have an angle, now I have a side.
Side angles.
Okay, look, angle, side, right?
Yes.
What else could I
Angle,
use
side.
or need? What else can you infer from that picture? If those lines are parallel, what is SA to those lines? Kayla said it earlier.
Transversal.
A transversal, what do transversals give us?
Right angle.
What? They give us something with angles, what do they do?
They give us another angle.
Well, what happens, if I have a transversal that cuts through two parallel lines, what happens?
Cut in half.
Equivalent.
Okay, equivalent angles, but how? Using what?
Vertical.
Not vertical, are there any vertical angles there?
Parallel.
No. Remember that this line, you could picture it as cutting through these lines right here. Okay, I could picture it like this. Pretend that those continue, right? What happens with this angle here and this angle here?
Oh, alternate.
Ah, alternate interior angles. You've got to be able to realize that when it's in a square. Okay? So, I would say angle,
S.
no, you want S to be the middle because it's the angle you're going for. So angle AST is congruent to angle, what corresponds with A? Oh, yes, is S, S-A-T, S-A-N. That's the one I use.
Oh.
Okay, and you said why?
Alternate.
Alternate interior. Now, what do you have to prove? You have an angle, you have an angle, and you have a,
Side.
so you're going to say triangle S-A-N is congruent to triangle A-S-T using what? Angle, angle, side. You have to start to be able to recognize that. If you need to extend those pictures out so that you can see that, do it, okay? But you have to be able to recognize that so that you can say, oh, that's a transversal. It gives me alternate interior angles. I could have also used this angle here and this one here, and it would still be angle, angle, side. Doesn't matter which one you use, okay? That is all we're doing today, okay? Let's get busy.